Hey guys, welcome to another video. My name is Captain Sanjit and today we'll be talking about the International Standard Atmosphere, or the ISA as we call it. Now this is going to be very useful in your future aviation life. Now when it comes to International Standard Atmosphere, what comes into your mind? It's a standard atmosphere created for aircrafts, right? Now, this concept has been created by an organization called as ICAO, or International Civil Aviation Organization, which we'll be talking about soon when we come to air regulations, and I'll be starting it soon side by side. But what I want to talk about is the three factors that is density, pressure, and temperatures. So the standards has been set for these three factors and other few factors as well, but today we'll be talking about pressure, temperature, and density, these three factors, right? So I have written it down in advance for you. So there is density, pressure, and temperature, and there's a standard set at sea level and certain altitudes for all these factors. So these numbers, I just want you to remember three numbers, and this you have to remember all your life, right? So when it comes to density, I want you to remember 1.225 kg per meter cube. For pressure, I want you to remember, this is very important guys, 1013.25 millibars. And for temperature, I want you to remember 15 degrees Celsius. So more than the density part of it, you'll be constantly using these two numbers to calculate many things throughout your life. Let it be in graphs, let it be in performance, etc. Okay, so why is this used? So these three numbers are standard at sea level. Now why is it standard? So that instruments can be calibrated accordingly, right? Why should instruments be calibrated at these numbers? So let's say this is the sea level, right? There are two aircraft, one is at 10,000 and one is at 8,000. Now, the altimeter is calibrated as or works as per pressure. The altimeter is all about pressure differences, right? So, if let's say this aircraft is set at a different pressure value and this aircraft is set at a different pressure value with respect to the sea level, what will happen is when they are actually flying, the values wouldn't be actually correct, right? So that's why if both are set at standards, let's say both are set at 1013.25, the pressure, the standard pressure, they'll both get the correct altitudes with respect to each other as well. So now this is at 10,000, this is at 8,000. If both are set at different pressure values, there are chances that this aircraft might not be actually at 10,000 or maybe actually at 10,000, but this aircraft can also be higher or lower, and that can result in an accident. So there are small pressure discrepancies always, but there is a standard kept so that there can be separation maintained between aircrafts, ATC gets to know, and etc. etc. But you get the gist of it. There are standards so that the instruments can be calibrated, the aircraft performance can be compared, etc. 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 right? So basically it is for comparison purpose, so that a standard is set for the same reason. A standard is set, and when a baseline temperature, pressure, and density is set, what happens is that everybody is on the same base. Everybody flies off the same standards, right? So remember these three numbers. I want to remind you again. Density is 1.225 kg per meter cube. Pressure, important, 1013.25 millibars, right? And temperature, 15 degree per Celsius. Remember these three numbers throughout your life, guys. Happy landings. Cheers. I'm trying to be on a video marathon for today because I know I haven't posted for a few days. So yeah, let's see how far I go. Happy landings. Cheers.